Okay, this video is to address solving a couple of systems by the method of your choice. And that includes an application problem on the next page. Remember, we've learned three ways to solve systems at this point. You could solve by graphing, you can also solve by substitution, or you can solve by the method of elimination, or what's sometimes called linear combination. Now, I would recommend starting off with one of the two algebraic methods, either substitution or elimination. Looking at the system over here at the left, noticing that I just have a 1x in here, that makes this a great opportunity to use either substitution or elimination. But let's go ahead and do substitution on this one. Remember, the main idea for that way of solving is to get your variable by itself. And since there's just an x all by itself already, if we add our 2y over to the other side, we simply have a great equation equal to x, which means I can put that right into my second set of equations. 2 times x, which is 2y plus 3, minus 4y equals 7. Again, taking out x because we know what x is equal to. Then we simply solve. 4y plus 3 minus 4y equals 7. And if we add our like terms, you're noticing that this is actually a special case. 3 equals 7 is an impossible statement, and since that can never happen, you'll find out that this is actually a system with no solution. Normally, if we had found x or found y at this point, since that's what we had left for a variable, we could have substituted it back in, found x, and had a point that we solved. But the fact that we got an impossible statement tells us that if we had solved this by graphing, you'll notice at the bottom, we've got the graph down here, that this comes out to actually two parallel lines. We've got a slope of 0.5 in both equations, but different y-intercepts, thus the no solution. We shouldn't find an algebraic solution, given that there isn't one on the graph to begin with. Let's go ahead and solve the system on the right by the method of elimination. You'll notice there's a lot of larger numbers, which sometimes makes for trickiness if we go to try to solve by substitution. You're going to have to deal with a lot of fractions. Instead, I'm going to go ahead and notice that y has a coefficient of 10, and down here on the bottom, y has a coefficient of 25, which means if we multiply our top equation times 5, we can get 30x minus 50y equals 60. And if we multiply our bottom equation right here by 2, you're going to have a negative 30x plus 50y equal to negative 60. And you'll notice that this time when we add up both of our equations, all of our x's disappear, all of our y's disappear, and we actually end up with 0 equals 0. Now we did lose both of our variables, but because this is still a true statement, remember that this is actually infinitely many solutions. I always have trouble spelling, of course. Infinitely, there we go, many solutions. And remember, that happens because technically, if we take a good look at our two equations, they're really the same equations to begin with. And if you go on to a graph, pop up our graph here real quick, you'll notice that I graphed both of my equations, both f1 and f2, using my original numbers, just moving things all over to the one side. But notice you can only actually see one of the two lines, because technically they come out to the exact same equation. 6/10 is 3/5, 15/25 is 3/5. They have the same slope, and 12/10 is 6/5, 30/25 is 6/5, and they have the same y-intercept. So if they're going to be the same line, of course, you're going to have infinitely many solutions, and algebraically it looks like that. Now, to solve a system that does have one solution, but show you where this can apply to the real world, here's an example of a real-world problem that you could solve using either substitution or elimination. At Santelli's Pizza Pies, it costs $4 to make a small pizza, but a small sells for $12. It also costs $6 to make a large, but larges sell for more. They sell for $15. In 1 week, the restaurant spent $1,100, but made or took in $2,910. Find the total number of each size pizza sold. Well, first of all, we need a set of equations. So we know that it costs $4 per small pizza. And let's go ahead and say that x will equal small and y can equal larges. So 4 times x, and realize it costs $6, so making a total equation of just cost, 6y, well, our costs for the week were $1,100. Also, we know that we make $12 per small pizza and $15 per large, and our total income was $2,910. So now we can go ahead and take a good look at our equations and decide, should we use substitution, elimination, or we could even use graphing if we wanted to. I tend to use graphing more as a way to check my answers, but you could always use it as your first resort. I notice though that 4 and 12 are pretty relatable. In fact, if I multiply that first equation times -3, I'll actually end up with a -12x, -18y, and a -3,300. And if we add those together, 12x minus 12x disappears, 15 minus 18 is a -3y, and 2910 minus 3,300 is technically $390 there. Divide by, a negative $390. Divide by -3, and you'll end up with 130 pizzas. So we know that we made 130 large pizzas. Then, of course, take one of your two equations, doesn't really matter which one. So I'm just going to say 4x plus 6y equals $1,100, which means 4x plus 600 is 780 equals 1,100. 4x equals, well, $20 would make this 800, so if we subtract that off, that should be 320, and divide by 4, and we should have made 80 smalls. So, final answer, we made 80 small and 130 large pizzas. Now again, you can always check that by graphing. All you have to do is go onto your calculator and enter in these equations solved for y. So go ahead and solve them for y real quick. Pop it in your equation or pop it into your calculator and see what you get. I'm going to pause the video now to give you a little bit of time to do that, and then we'll show the calculator solution when we're done. Alright, so you'll notice in purple here I've solved my equation for y. All I did was very simply subtract my x term and divide by my coefficient of my y. So 1100 minus 4x over 6. Same thing with the second equation down here in purple right in the middle. 2910 minus 12x over 15. On my calculator, my two lines look like this. I had to expand my screen a little bit. Notice that my y's are going up to 300, so do my x's. But notice right here in the middle of the screen, we've got that nice intersection point. And remember that we can go to Menu, Analyze Graph, and find a point of intersection. And all we have to do is do a left bound, right bound. So I'm going to make that little dotted line be to the left side of my intersection point. And then if I pull across where those two lines cross, you'll notice we get a nice intersection point after clicking twice of 80, 130, which is exactly what we had on our screen. 80 small pizzas, 130 large pizzas for a good solution. I hope that helps you with solving systems of equations. Good luck and have fun.